Okay, let's add and subtract rational expressions. But first, let's do a little reminder on adding and subtracting fractions. Now, when you're adding and subtracting fractions, like let's suppose you have 3/7 plus 5/2. You know that you can't add the denominators. You have to have a common denominator in order to add these two fractions together. They can't be added in this form. So, we take the first one and we multiply it by 2 over 2, and that will give me 2 times 3 is 6, 2 times 7 is 14. And then we take the second one and we multiply it by 7 over 7, and that will give me 35 over 14. So we have 6 over 14, which is equal to this fraction, plus 35 over 14, which is equal to this fraction, and now I can add them because I have the common denominator. Okay, so 6 plus 35 is 41. So this is my result. Now that's how you add and subtract fractions. Well, it's not too much different, except it's a little more complicated when you add and subtract rational expressions. Let's try a simple one. Suppose you have 2x over x plus 3, and you're adding 5 over x plus 3. Now the first thing you notice is that these two do have a common denominator, x plus 3. So that's the common denominator. So what you do is you just add the expressions on top. You say 2x plus 5 over x plus 3, and that's the end of that. How about one's a little bit different? How about x squared over x minus 3 minus 9 over x minus 3? Once again, you see we have a common denominator. So we don't have to do anything fancy with our denominators. We don't have to multiply or anything like that. So we got x minus 3, and on the top we have x squared minus 9. Now some of you have already figured out we're not done yet, because this can be factored. Okay, this is x plus 3 times x minus 3, and that's over x minus 3. And so of course I can cancel this, and I can say my result is x plus 3, but I also have to add x cannot equal 3. Why can't x equal 3? Because if x is equal to 3, I would have 0 in my denominator in my original expression. So keep this in mind, okay, when you're looking at these. Keep this in mind. Always look at the original expression and find your domain restrictions, because we're going to be doing functions pretty quickly, and we're going to have to remember this stuff. So how about one a little bit more difficult, a little trickier, where we actually do have to find the least common denominator. So let's find the common denominator. X over x minus 2 plus negative 8 over x squared minus 4. Now, the first thing I see here is that x squared minus 4 can be factored into x plus 2 times x minus 2. And I can see that this is a factor of this. It's x minus 2 and x minus 2. That means if I multiply the first fraction, or the first rational expression, by x plus 2 over x plus 2, then I will have x times x plus 2 over x minus 2 times x plus 2. Now this is equal to this. Not as simple, but it is equal to that. Why did I do that? Because I've got negative 8 over x minus 2 x plus 2. Okay? So, now let's multiply this out. X times x is x squared. X times positive 2 is positive 2x. And then I've got minus 8. And this is over. This is my common denominator now. This is why I did all this stuff here. X minus 2 times x plus 2. Now, what does that reduce to? I can factor this numerator, x plus 4 times x minus 2. 4x minus 2x gives me positive 2x. 4 times negative 2 gives me negative 8. So, I've got now something that's pretty simple. X plus 2. And you can see I can cancel now this and this. So I end up with x plus 4 over x plus 2. And this is my final result. And again, I have to look at my domain restrictions. X cannot equal 2 or negative 2. Why can't it be negative 2? Because look, x squared minus 4. You've got two denominators here, and in both cases, 2 and negative 2, or in either case, 2 and negative 2 would not work. Okay? Anyway, so this is my final result, and this is what I started with. This is what I finished with. Notice, this is not something you're going to be able to, oh, we'll skip all that fancy stuff the teacher told us, and we'll just get zoop right to the end. This is not something you can do in your head. And what happens is, the first time we have a quiz over this kind of material, you can really tell who understands how to do it and who doesn't. All right, so let's try something new. And we've got time for a new color. Just a moment here. Let me catch up with my notes. And here we go. 6x over 3x minus 1 minus 4x over 2x plus 5. Now the first thing you might notice here is there's nothing at all in common between these two denominators. So there's only one thing we can do, and that is 6x times 2x plus 5 over 3x minus 1 times 2x plus 5. What I did is I multiplied the numerator and denominator in the first case with the 2x plus 5 over 2x plus 5. And subtract 4x over 2x plus 5 times 3x minus 1 over 3x minus 1. Remember, this right here, this is equal to 1. Okay? So what I'm doing is I'm taking this and I'm multiplying it by a number that's equal to 1. So I'm not changing the value of this fraction, I'm only changing the form. And as you can see, now I have my common denominator, which is 2x plus 5 times 3x minus 1. Of course, you know that because of the commutative property, I can put these either 3x minus 1 first or 2x plus 5 first. These are equal to each other. So what about the numerator? Well, let's see. I got 6x times 2x, which is 12x squared. I've got 6x times a positive 5, which is positive 30x. Now I'm going to take this and match it up with my 4x. And so I have negative 4x times 3x, which is negative 12x squared. and negative 4x times negative 1, which is positive 4x. So of course I can simplify this top. 2x and 12x squared rather, and negative 12x squared cancel. And 30x plus 4x equals 34x over 2x plus 5 times 3x minus 1. This is actually as far as I can go. Now, if I want to, I can multiply out the denominator, and I've got 6x squared plus 13x minus 5. Now, I'm going to show you a neat little trick. I'm going to put this into my calculator as y1, and I'm going to put this into my calculator as y2, because this is an excellent way to check to see if you've done this correctly. And I've already done this. Now, I want you to notice something. When I put this into my calculator, I put this in parentheses, I put this in parentheses, and I put the whole thing in parentheses, and the same over here. And I've already done this, so let me show you what that looks like in your calculator. Parentheses, that's this big one. Another parentheses around 6x. Then the divided sign, this bar right here. And then parentheses around 3x minus 1, and then close parentheses. So you've got the first fraction right there. Then subtract your minus sign, and then another set of parentheses. And it's a whole lot better to use an extra set of parentheses if whether you think you need it or not, than it is to leave off a parentheses that you might need and you get something totally wrong. Okay? Now look at y2. Very simple. 34x parentheses, inside parentheses over parentheses 6x squared plus 13x minus 5. Now, this is my graph. I already graphed that. If you want, I'll change the window. Go to Zoom Standard and watch. You see this little thing on the right, it's still working. You see, it looks like it's done now, but look, it's still working. And so that means that you've got both graphs on there now. And if you don't see a difference between those two graphs, that means that the two graphs are on top of each other, and so you've done your calculation correctly. If you see a different graph showing up here than the first one, like when it starts to build the second graph, you see a different graph being built here, then you know you've made a mistake somewhere with your algebra. All right, let's try another one. This time, I've got a real good challenge for you. This is 1 over 1 plus 1 over a plus 1 over 1 minus 1 over a. Now you guys are going to be kind of surprised at what this ends up being. So bear with me, because what we have here is a lot of small steps. Each step is relatively simple, but there's a lot of small steps that have to be done in order and have to be done correctly. So let's look at, first of all, let's look at this right here. 1 plus 1 over a is equal to, remember 1 is equal to a over a plus 1 over a. Notice that I just changed the 1 to a over a. But now I have common denominators, okay? Because I can't just add 1 plus 1 over a. I have to change this to a over a. So now I have a plus 1 over a. On the same token, look at this one. Same deal. I've got 1 minus 1 over a equals a over a minus 1 over a. So that gives me a minus 1 over a. So rewriting this whole thing with this new information looks like this. 1 over this doodad. A plus 1 over A plus 1 over this one. A minus 1 over A. You see what we've done here? We've gone from here to here. Now, the thing to remember is that when you divide, or when you have this thing here, it means divide. And so now we have 1 divided by A plus 1 over A plus 1 divided by A minus 1 over A. 1 divided by, this bar here means divided by, A minus 1 over A. And of course, in order to do that, I've got to flip this fraction upside down, the second one. So, I have 1 times A over A plus 1 plus 1 times A over A minus 1. What does that mean? You see what I did here? I changed this one, the divided sign, to a multiplication sign, and then flipped this second fraction upside down. Did that in both cases. Change this to a multiplication, change this. Now, of course, you know that 1 times anything means that that's all there is, A plus 1, A over A plus 1. So 1 times that means I can just get rid of the 1. So I have A over A plus 1 plus A over A minus 1. Now you see where we've gone from this yellow one down to where we're at right now, A over A plus 1 plus A over A minus 1. Now, if I multiply this one times A minus 1 and A minus 1, and multiply this one times A plus 1 over A plus 1, then I'm going to have common denominators, which is A plus 1, A minus 1. That's my common denominator. What do I have on top? I have A times A is A squared. A times negative 1 is negative A, plus A times A is A squared. A times 1 is plus A. Simplifying, cancel, cancel. What do I have? A squared plus A squared, which is 2A squared, over. Now these are conjugates, and so conjugates end up being A squared minus 1. And I can't do anything with that. Now, every once in a while the question comes up, can I cancel the A squared with the A squared? Please note, this is A squared minus 1. You cannot cancel, you can only cancel factors, not terms, okay? So you can only cancel, if I had an A plus 1 on the top, I could cancel A plus 1 top and bottom. If I had an A minus 1 on the top, I could cancel top and bottom. A squared, I can't, because that's, if this were A squared times something, then I could cancel it. But it's A squared minus 1, so I cannot cancel. Please don't do that. That's all I have for you today, except for the practice, which is page 509, 4, 6, and 8, and the homework, page 509, 10 through 40, every third problem. Thank you.